Good morning, students. In the previous session, I had started the next application of the derivative, that's known as maxima and minima. I just gave you the definition of the meaning of maximum value, maximum point, minimum value, minimum point, and I defined about the local maximum and local minimum points as well as the values. And under that now you learnt about a first derivative test. It can be considered as a theorem also. With the help of the first derivative, we can just find out how the function is behaving, whether it is attaining a maximum value or a minimum value, which is called as a local maximum or local minimum value. So, in that one now, if f dash x changes sign from positive to negative at a particular point, then it is called as a maximum point, and if it changes from minus to plus, it is a minimum point. So, the values of the functions at those points respectively can be called as maximum values as well, value and as well as minimum value. Now, I told you in the previous session itself there is one more test called as the second derivative test. That is what I am telling you now. Now, this also is considered the statement of a theorem. Here, we consider a function f and defined on an interval. Consider a function f defined on an interval I. Now, let C be a point in belonging to the interval. So, let the function f be defined on an interval I. Let C be a point belonging to I here. Now, here and consider the function which is twice differentiable at the point. In other words, f dash waste double dash C exists. That is the meaning of that one. So, f is a function defined on an interval and C being a point in the interval, and also the function is twice differentiable at the point C. In other words, f double dash C exists. Now, three cases we consider here. If f dash C is equal to 0 and f double dash C is less than 0. So, when you take f dash C equal to 0, you get the values of x here. Then f dash x equal to 0, that means you find the critical point. If f dash C is equal to 0 and f double dash C is less than 0, that means it should attain a negative number, negative value, then that C is a point of local maxima, or you can say local maximum point. So, C is a point of local maxima, or you can call it as local maximum point. The point C is called as local maximum point. Now, when you go to the function here, suppose you find the value of the function at the point C, this is called as local maximum value. See, usually negative means we think it is less, so it is not so, be careful. So, the first derivative should be 0. Second derivative should be less than 0. So, like that you remember, then that point is called as local maximum point. The value of the function at that point is called as local maximum value of f. Similarly, we consider the second possibility, that is, second case is if f dash C equal to 0 and f double dash C is greater than 0, that is, it is a positive quantity, it is a positive quantity, then we call C as a point of local minima. It is called as a point of local minima, and f of C is called as local minimum value. So, when f dash C would be 0 in both the cases, okay. If the second derivative is negative, less than 0, it is a maximum point. If the second derivative is greater than 0, it is a minimum point, and the value of the function at that point is called as the local minimum value. What is the third possibility? F dash C is always 0. F dash C is 0 and f double dash C may also be equal to 0 in a particular point C. then we call it as, we cannot take it as a maximum point or a minimum point. So it is neither a maximum point nor a minimum point. We call that point as a point of inflection. Okay, that is, first derivative is 0, common for all the three possibilities. Is the second derivative less than 0? It's a maximum point. Second derivative greater than 0, it is a minimum point. Second derivative equal to 0, it is called as the point of inflection. About this I have mentioned in the previous session when we are discussing about the definition of the local maxima and minima. Now, for all the problems, that is for the problems given when the functions are given directly, or for the statement problems, we use the second derivative test. It is easy to apply to know about the maximum point, minimum point, or maximum value or the minimum value. Now let us start working out some problems here. The common instruction is find the local maximum and local minimum values. Sometimes they ask you to find only the points here, but usually they ask you to find the maximum values and minimum values. Sometimes the word local may not be specified, even then you follow the same procedure. So find the local maximum and local minimum values. Now let me consider the first problem. F of x is equal to 2x minus 1 the whole square plus 3. Now better you follow the second derivative test. It is easy, using that one it's easier to get the result quickly. Now 2x minus 1 whole square plus 3. One is you can expand this one using the formula a minus b whole square, then you go for the differentiation. So when a function, otherwise directly you can differentiate using the chain rule here, because it is a composite function. See, always as soon as a function is given, first you find the first derivative, you find the second derivative. You can take this as 1 because we use this afterwards to find either the maximum value or the minimum value. Now immediately you find the first derivative, f dash x. So apply the chain rule, something raised to the power 2 into, that is 2 into 2x minus 1, n into x to the power n minus 1. Again 2x minus 1 has to be differentiated, whose derivative is 2. For 3 it is 0. So we are having f dash x equal to 2 2s of 4 into 2x minus 1. You have this one. We need it afterwards to find the critical point. Now go for the second derivative, f double dash x. This has to be differentiated. 4 into, it is 2 into 1 and this would be 0. Hence we are having 8. So what is the value here? Plus 8 we got. That means that it is greater than 0. See, we are not interested in the actual value of this one. For the second derivative. Second derivative, we are interested only to know whether it attains a negative value or a positive value. So positive value means that gives only that tells us what type of point it is, what type of value it would be getting. Therefore, it is greater than 0. That is, you write the function attains a minimum value, or you can write local minimum value. That's why it is called as the second derivative test, because we use the second derivative just to know whether what type of value it is attaining. It is a maximum value or a minimum value depending upon the sign of the second derivative. Because it was a quadratic function, we got it a constant directly. Suppose that were to be a cubic or fourth degree, you have to directly will not be getting, we have to write the value of x and then find out. So at present we got the value directly, it is a positive number, that means the function attains a minimum value. To know the critical point or which is the minimum point, always you have to equate the first derivative to 0. So as soon as the function is given, find the first derivative, find the second derivative. Then you equate the first derivative to 0. What is the first derivative? That is 4 into 2x minus 1 equal to 0. 4 cannot be 0, that is 2x minus 1 equal to 0 implies x is equal to half. That is, this is the only critical point we are getting. X is equal to half is the only critical point. See here, because we don't have any x, the variable, if there were to be some variable, we should have substituted the value here of x here and found out whether it is attaining a positive value or a negative value. Directly we got it to be a positive value, directly we got the information that it is attaining a minimum value. So x is equal to half is the only critical point, or critical point, or in this case now you can write it is a value, I mean local minimum point you can write, critical point you can write, which is because we have seen that one, which is a point of local minima. There is only one critical point, that is nothing but a point of local minima. We are interested in finding the local minimum value. Therefore, the local minimum value. How do you calculate this one? You go to the first relation. Put x is equal to half in 1. In 1, that is f of half would be equal to 2, wherever x is there, write that value, 2 into half minus 1 the whole square plus 3. 2 and 2 they get cancelled. 1 minus 1 whole square plus 3, that is 0 plus 3. Hence the local minimum value is 3. It attains only minimum value. It does not get any maximum. We cannot say this is the exact maximum value. So this function attains only a local minimum value. It does not attain a maximum value. Now let's move on to the next problem. In the next problem, I am giving you a polynomial function only, but it is a third degree polynomial function. So naturally, instead of 1 point, you will be getting 2 points here. Now consider the function f of x is equal to x cube minus 3x. Now this is the next function, x cube minus 3x. Now let us say first always take it as 1. Now differentiate f dash x equal to 3x square minus 3, or you can take out 3 as common factor, it is x square minus 1, or you can keep it as it is, it's also no problem, that is f dash x. Okay, now have this. Differentiate again, because we are using the second derivative test. As soon as a function is given, differentiate once, differentiate 2 times. Now 3 into x square becomes 2x, that would be equal to x. Okay, this is the second derivative. See, in the previous problem, we got directly a constant. So we could come to the conclusion it is attaining a minimum value. It is not possible here. So what I have to do? First take the function as 1, differentiate once, differentiate 2 times. Next, let us calculate the critical point. Let f dash x be equal to 0. What is f dash x? That is 3 into x square minus 1 equal to 0. 3 cannot be equal to 0. That is x square minus 1 equal to 0. That implies x square equal to 1. Therefore, x is equal to plus or minus 1. So here we got 2 values. Already I told you, if the given function, polynomial function is of third degree, you will be getting 2 values. That is, you write x is equal to minus 1 and x is equal to plus 1 are the critical points. See, in the previous problem, there was only 1 point. Directly we could say it was a minimum point. Now there are 2 points. These are 2 critical points. We do not know at minus 1 what happens, at plus 1 what happens. Now that has to be calculated by giving the values of x in the second derivative, because we are using the second derivative test here. So one by one we will consider. Like at x is equal to minus 1. I am taking this one. Consider the second derivative, that is f double dash minus 1. What is f double dash here? 6x, that is it is equal to 6 into minus 1, 6 into minus 1, that is minus 6 less than 0. Minus 6 less than 0. See here, don't worry about the value. We are interested only in the sign. So the second derivative, when x takes the value minus 1, the second derivative is minus 6 less than 0. So what is our conclusion? When it is negative, second derivative is negative at a particular point, it is a point of local maxima. That is, you write x is equal to minus 1 is a point of local maxima. See, when you know that it's a point of local maxima, it is better to calculate the maximum value immediately. Therefore, you write the local maximum value. How do you obtain this one? Put x is equal to minus 1 in the first equation, the given function. That is, f of minus 1 is equal to minus 1 the whole cube minus 3 into minus 1. Therefore, minus 1 plus 3, that would be equal to 2. So, we got here the value plus 2, that is the local maximum value of the function which is attained at the critical point x is equal to minus 1 is equal to 2 here. The local maximum value is 2. Now, what is the other point we are having? One we have tried. Now, let me consider the second point. At x is equal to plus 1, consider the second derivative. F double dash 1 is 6 into 1, that is 6, that is greater than 0. That is, you write x is equal to 1 is a point of local minima. Is a point of local minima. Immediately you write, therefore, the local minimum value. Therefore, local minimum value is put x is equal to 1 in the first equation. That's why I had given a number there. That is f of 1 equal to 1 cube minus 3 into 1, that is 1 minus 3, that is equal to minus 2. So, what did we get here? The local maximum value which was attained at the point x equal to minus 1 is equal to plus 2, and the local minimum value which was attained at the point x is equal to plus 1 is equal to minus 2. So, the maximum value plus 2, the minimum value minus 2. So, this is how you have to find out. So, remember the procedure here. First, you take the function to be, if fx is given, you take fx, or else you can take it as y also. So, first find give it a number, preferably 1. Then you differentiate once, you differentiate twice. For the statement problem as well as for all the given functions also, we use the second derivative text. It is easier to find the minimum maximum values as well as the points. Now, the next function I am considering is a trigonometric function. Fx equal to sin x plus cos x. Here there is some restriction for the domain. That is, what is the domain here? It is 0 less than x less than pi by 2. It is an open interval. It's an open interval. I am considering x belongs to the open interval 0 pi by 2. It does not take the value 0. It does not take the value pi by 2, which lies between 0 and pi by 2. All the values x is taking. The procedure is same as usual. Let me consider this as 1 and find the derivative. First derivative, sin x becomes cos x and cos x becomes minus sin x. This is a given function. This is the first derivative. Let me calculate the second derivative. Cos x becomes minus sin x and this is minus cos x. This is the second derivative. So, our first step is always differentiate once, differentiate 2 times, keep them ready. Now, to know the critical point, always equate the first derivative to 0. Because you know that either it is a maximum point or a minimum point, the first derivative will always be 0. That implies that, what is the derivative here? Cos x minus sin x is equal to 0. That is, we have to get the value here. It is a trigonometric function we are having. Cos x minus sin x equal to 0. Or you can take cos x equal to sin x. Now taking cos x to this side, 1 would be equal to sin x divided by cos x. What is sin x divided by cos x? It is tan x. Tan x equal to 1. Now we have to get the values of x here. If this were not to be given, or if the interval were to be 0 to 2 pi, all the 4 quadrants it considered, then we would have two values of x, because tan x is positive in the first as well as in the third quadrant, whereas it is considered only in the first quadrant, that too it is an open interval. So what can be the corresponding value for x here? That implies that x is equal to pi by 4. So we are getting only one value of x here. X is equal to pi by 4 is the critical point. So in this case I got only 1 point. In the previous problem I got 2 points. So at this point x equal to pi by 4, we want to know whether it is attaining a maximum value or a minimum value. How do you find out? You have to always refer the second derivative. Therefore, to know whether it is a minimum point or a maximum point, first put that value in the second derivative. Put x is equal to pi by 4 in f double dash x. Okay, that is, write like this, f double dash pi by 4 is equal to, come to this one, minus sin pi by 4 minus cos pi by 4. Okay, let me write the value. See, here itself you can directly write, it is negative because both of them are negative. Minus 1 by root 2 minus 1 by root 2, it is certainly less than 0. There is no need to take the LCM and simplify. We are interested to know only whether it is negative or positive. Since both of them are negative, the sum will also be negative. So it is less than 0. So less than 0 means what is your conclusion? The function is attaining a local maximum value. That is, you write at x is equal to pi by 4, the function fx attains a local maximum value. Local maximum value. So this is only for confirmation. The second derivative is used only for confirmation whether it is attaining a maximum value or a minimum value. Or you can write like this, x is equal to pi by 4 is a point of local maxima. Or you can write x equal to pi by 4, fx attains a local maximum value. Both mean the same thing. Therefore, you write, therefore, local maximum value. How do you find this one? Is equal to, put x is equal to pi by 4 in the given function, that is 1. That is, f of pi by 4 is equal to sin pi by 4 plus cos pi by 4. Now, it's 45 degrees means the standard value 1 plus 1 by root of 2 plus 1 by root of 2, adding 2 by root of 2. On simplifying, we get the local maximum value of the function which is attained at the point x equal to pi by 4 is equal to square root of 2. Okay. So, it is attaining only one value here. See, depending upon the function, sometimes it may attain two values. There may be 2 points here, and one point it may be maximum, another point it may be minimum, third point again it may be maximum, or third point may become a point of inflection. See, unless we verify with the second derivative, we cannot come to any conclusion at all. Now, in the next problem also, I am considering a third degree polynomial function. So naturally you will be having two two points which are called as the critical points. Let me consider the next function. F of x is equal to x cube minus 6x square plus 9x plus 15. So, x cube minus 6x square plus 9x plus 15. Now, as usual, let me take the given function to be equal to 1. Now, let me differentiate f dash x equal to, it's a simple algebraic function, x cube becomes 3x square minus 6 into x square becomes 2x, that would be 12x, 9 into 1 that is 9, 15 being a constant becomes 0. So, you can stop here. Now, let me calculate the second derivative also, f double dash x. So, 3 into x square that would become 6x minus 12. Now, this is the second derivative. So, as soon as the function is given, first you do these two steps here. Differentiate once, differentiate two times. Then let us find the critical point. Equate the first derivative to 0. Let f dash x be equal to 0. That is, what is f dash x here? 3x square minus 12x plus 9 equal to 0. Now, you observe 3 can be taken as a common factor. It becomes x square minus 4x plus 3 equal to 0. See, a product is equal to 0. So, 3 cannot be 0. That implies that x square minus 4x plus 3 equal to 0. See, you are familiar with the solution of a quadratic equation in your high school classes. So, x square minus 4x plus 3, when you factorize, you are getting x minus 3 into x minus 1. See, I am not showing that one, you are supposed to do that calculation. Because when you multiply minus 3 into minus 1 plus 3, when you add them you are getting minus 4x. You know the procedure, how to factorize that one. Just splitting the middle term as the sum of the two terms. So that the sum would be the middle term, the product would be the last term. Therefore, by equating you can write x is equal to 1 and x is equal to 3 are the critical points. See, equating the first derivative to 0 gives us a critical points, and putting these values in the second derivative gives us the information whether it is attaining a maximum value or minimum value. To get the minimum value, maximum value, you have to go back to the given function. So, all the three, for one reason or the other, we will be using the all the statements here. Now, one by one we will consider. At x is equal to 1. Or you can say put x equal to 1 in second derivative, that is f double dash 1, come to this one, is 6 into 1 minus 12, 6 minus 12 minus 6 less than 0. So, second derivative is negative at a point, means in the statement I had given c, that c has got the value 1, that is all. So, at the point x equal to 1, f double dash 1 is minus 6, which is negative. That is you write x is equal to 1 is a point of local maxima. Now, this is only for confirmation, but we are interested in the values also. Therefore, put x is equal to 1 in the first one. That is, go to the first function, given function. F of 1 is 1 cube minus 6 into 1 square plus 9 into 1 plus 15. That is 1 minus 6 plus 9 plus 15. So, when you simplify 15 plus 24, 25 minus 6, that would be equal to 19. So, write that one. Therefore, the local maximum value is equal to 19, because as soon as you know this point of local maxima, better you find the value immediately. Okay. Otherwise, while writing the conclusion, there may be some mistake. Now, let me take the second point at x is equal to 3. X is equal to 3. Let me consider the second derivative. F double dash 3. How do you write that one? 6 into 3 minus 12. That is 18 minus 12. 6 that is greater than 0. So greater than 0 positive. That is you write x is equal to 3 is a point of local minima. So since the second derivative less than 0 maxima, second derivative greater than 0 minima. Therefore you write put x is equal to 3 in 1. We get the local minimum value. Local minimum value is equal to, in that first function, given function, put x equal to 3. 3 cube minus 6 into 3 square plus 9 into 3 plus 15. Look here, 3 cube is 27, 3 square is 9 6 are 54, 9 3s are 27 plus 15. Now you observe 27 plus 27 54, they get cancelled. Finally what do you get here? 15. So you can if you want you can write again. Therefore local maximum value is equal to 19. Local minimum value would be equal to 15. Like that, two statements afterwards also you can write here. Otherwise as soon as you get it, you just underline that one so that whoever values your paper will be looking at those values. So this is the procedure we adopt whenever we have more than one critical point. If there exists only one critical point, whether 1 point, 2 point or 3 points, the procedure is same. First you take the given function, give some name, or you can keep it as it is also. Find the first derivative, find the second derivative. Equate the first derivative to 0. Get the critical point or points. Then write those values of x which you have obtained here in the second derivative. If the second derivative is less than 0 or negative, it is a point of local maxima. If the second derivative is greater than 0, that is positive, it is a point of local minima. If the second derivative is also equal to 0, it is a point of inflection. Okay. So if you see that it is a local minimum point, go to the given function and write that value there, you get the local minimum value or maximum value depending upon what is your conclusion when you consider the second derivative. So because we are using the second derivative, all these problems they are coming under the second derivative test. So in the coming sessions also I will be working out some problems, whether it is a given function or we may have to form using, suppose a statement problem is given, you have to form a function depending upon the condition that has been given in the problem, and then the same procedure we are following. Find the first derivative, second derivative, get the critical points, verify with the second derivative, then get the maximum or the minimum value. So in the coming session, let us work out some more problems of maxima and minima. Thank you.